We have two transformations of the quadratic parent function, y equals x squared. And so it's worth noting that y equals x squared is a parabola. It has vertex at 0, 0. Here we see transformation number 1 is in the vertex form, y equals a times the quantity x minus h squared plus k, where in this form we know that the h and the k give us our vertex. So we see that our vertex for this particular quadratic function is negative 3, 1, 2, 3, negative 8, 1, 2, 3, 4, 6, 7, 8. So we have negative 3, negative 8. So the first step is just to plot the vertex. We realize because the a is positive, the graph is going to open up. The parabola is going to open up. So I'm not going to be too concerned about where I draw this other than the vertex, and drawing it with a 4 there, we know it's going to be a lot skinnier than a normal parabola that has an a of 1. So when a gets bigger than 1, it becomes skinnier, wider if a is between 0 and 1, and so forth. So that's that, and we can start filling out the characteristics of this function. We know that the domain of all polynomial functions, which would include quadratic functions, is always all real numbers. X, such that x is an element of all real numbers. You can write it like that as well. So all the x values, we use all the x values to graph this function. So the domain is all real numbers. Now the range, we know the range is from the lowest y value to the highest y value. So we see the vertex being down here at negative 3, negative 8. There are no other lower y values than negative 8. So therefore, negative 8 is the beginning of the range. We include the endpoint of negative 8 with a bracket. And using interval notation, we say that the range is all real numbers greater than or equal to negative 8. We could also say that y is greater than or equal to negative 8. So we could do that as well. The increasing and decreasing, we've been using the red and the green. And before we do that though, let's go ahead and draw the axis of symmetry. And the axis of symmetry is the x value that cuts the parabola right down the middle. That's x equals negative 3. And we know that as x moves from left to right, from negative infinity all the way to negative 3, we can see that the y values are getting smaller on that interval. So we use red to represent that. And then we use green to represent the interval in which the y values are getting bigger. So we say that the function is increasing on the interval, the green interval here, from negative 3 to infinity. And that's that interval right there. The y values are getting smaller on the interval from negative infinity to negative 3. And we have no horizontal or vertical asymptotes on this graph. We'll get to the x and y intercepts later. We have no maximum value. We do have a minimum value. The minimum value is the beginning of the range, and that would be y equals negative 8. It's not 1-to-1 because the horizontal line would hit the graph at more than one point, which means that for one y value, there are two x values on some of these values. So if we draw a horizontal line, we can see, one y value, then we hit two values of x. So it's not 1-to-1. Slope is NA, meaning that we're only really concerned about the slope of a graph when it's a line. Now we could say though the slope is increasing. So if we go from negative infinity to positive infinity, the slope along the curve would be increasing. So let's go ahead and put that in there, increasing. And the vertex we already indicated is negative 3, negative 8, and we also indicated the axis of symmetry. Now be careful, make sure you write down the axis of symmetry using an equation. Don't just write the number negative 3 down. X equals negative 3 is the equation of the axis of symmetry.